on the same evening as Ines, who obviously is the star guest today, but I'm glad you stayed all along. So Sergi already said this, I'm one of the PyTorch developers, one of the independent ones. As you know, there's a lot of them who work at Facebook or NVIDIA. And I'm most known for accelerating some stuff either with the JIT, things like custom LSTMs, try to close the gap between cuDNN and what you can write in Python. And also, if you've used batch norm or something, I try to make that faster too. And for a year and a half, I've been working on my own company where I do specialist machine learning and PyTorch training. And so you ask, so MathInf is mathematics and inference, not mathematics and informatics. And so I keep a little machine learning blog. I'll try to keep this non-technical. Last time I was here, or I think it was at JetBrains, I had lots of maths in my talk. Today we're just going to look at applying things. But if you're into technical details of optimizing CUDA kernels, then that's a cool blog. What I'm going to show you is LibreOffice Translate. And so the idea is that, well, yeah, you have a sentence and it's in English, and I'm a simple person, I don't speak English. I just click here, translate English to German, and then it comes out as a German sentence, but it doesn't fit on the screen anymore. And so this is something where I really wanted to do something that runs locally and that I can actually install on my mom's computer and she can use it. I always do these fancy machine learning things, and I'll tell her, yeah, that's like Amazon's customers who bought X also looked at Y thing, but so here's something you can really use. And this is also a good opportunity for those of you who have cool ideas and also have the time to do them, but don't have the money to get through it. So the initiative development was sponsored through a program called the Prototype Fund, which is a real cool program where you, either as a single developer or as a group of developers, can apply for a grant to develop an open source product software for the public good thing, and you get up to I think 49,000 euros grants to develop a thing. If you're a software developer and you want to work on a medium-term project and not do it all for free, that's probably a good thing. And it fit very well for me. Well, the company still had to grow a bit. So that's maybe, and Sergi said that we're going to have a chat on some of these aspects too, how to get really into things. I can recommend this program if you have more ideas than you have time to work for free. And so why not just use Google Translate? That's obviously the elephant in the room. When I said, well, I'm going to talk about Euro machine translation, that's the first question. Well, sometimes privacy is a reason, both my own and possibly if you have data that is not your own data, you're not allowed to just post it into some internet service. There's also the comfort. If I have a document that kind of has formatting and images and stuff, it's a bit hard to paste that to Google Translate. You might be offline. I put a question mark here. I sometimes have this discussion, like, should you do machine learning on the mobile phone? If you were If you looked at PyTorch, they have a PyTorch mobile now, which TensorFlow has for a long time. And so actually, about a year ago, I did the initial Android port. And so I've been talking to people, and many people say, well, yeah, if you're on the phone, you're basically not offline. Probably depends on where you are, too. But in the European Union, that seems to be a fairly safe assumption. Well, and also you can do customization, so we can improve the models or create our own models for our favorite language pairs. And so by doing this in LibreOffice, one thing is you have a fairly large user base who can potentially use your translation software, but also you have a huge localization community, like LibreOffice is translated into African languages of all sorts, and into minority Taiwanese, or how to say it, into minority languages spoken in Taiwan or some places. And so there's a huge translation community and people interested in things like localization and also translation potentially. Sometimes there's also people, and I'll tell you that I've used a software that pre-existed, and they just show up here. Well, yeah, I have trained my model, but how can I deliver it to users? And obviously, if you have a solution there, you can help them out there too. But obviously, it's also fun to hack your own and have a product that's really suitable for end users. So I have used 3 things. LibreOffice Writer, obviously, that's where texts live if you want. I've used a project called OpenNMT that is one of the leading neural machine translation libraries developed by a company called Zistron and Harvard NLP, and they offer PyTorch and TensorFlow. You might be surprised that I used the PyTorch version. And then there's a little tool called Sentence Piece. And if you listen carefully to Ina's talk, there were the subword tokens that need to be mapped to proper words. And so this is a library that gets you the subword tokens, but not the proper words. If you look at these models, the flagship models are transformer models, just like BERT, but they are not actually BERT. And BERT would probably cover this encoder step, but then you have a decoder that kind of looks similar, but it has the task to always emit the next word, quite similar to what you do when you do language model pre-training. Who has looked into some detail into the transformer, how the transformers work? Who hasn't, but has the urge to look into that? Not that many people, okay. I'll spare you this slide, then I will just give you, and if you, we will either post the slides on the GitHub or I have a link with them. So there's a recommended reading from Sascha Rusch from Harvard NLP. Now he's at CMU, I think, called The Annotated Transformer, where he takes the transformer paper, attention is all you need, and he just takes the text literally and copy-pastes it into Jupyter and then builds the transformer model while he explains how it works. So it's a really great thing. And I'll just skip that because how you voted. So we have this. When we do translation, we want to, it would be best if we could translate just anything. Whether we will do that successfully or not is a second question. But so one of the dreaded things when you do NLP is this UNC token, the unknown word. For example, if you have the Traktor Reparaturwerkstatt, you will be hard-pressed to find the word vector for that. And so what people do, and I think Zenrich were the first to propose that for neural-machine translation, is to don't go for words and then try to find vectors, but you just take the alphabet as tokens, single letters, and then you look what combinations are common, and you combine those into a new token, and then you do this iteratively until you have some target vocabulary size of, say, 50,000 words or something. And so the good thing is here, if you don't throw away the single letters, you can, by definition, have any word represented, any text. And for the most part, those longer tokens, the higher order tokens, if you want, the merged ones will be words or parts of words. So that works fairly well. A slight complication in this is that tokenization isn't unique anymore, but for practical purposes, we just use the subword NMT model or sentence piece. You have a Python include, you dump your text in that, and you get the tokenized thing out. So that's easy. And we have this translation model that you can download from the OpenNMT website if you're looking at English to German, or I have a German to English model on the GitHub page. And so we can now try a translation. What do you think this will be translated to? The quick brown fox jumps over the lazy dog. Yeah, and I mean, it's no surprise, der schnelle braune Fuchs springt über den faulen Hund. Great. So what do you think this will be translated to? Any ideas? So I'll give you a hint. It starts with der schnelle braune Fuchs springt über den faulen Hund. And then what will happen? What do you think? Anyone? No one? Ines probably knows because she's seen all the things. Well, what happens is that it translates to der schnelle braune Fuchs springt über den faulen Hund and nothing more. And the reason is that the model was trained to translate one sentence at a time, and when it sees the end of a sentence, it says, well, yeah, I'm going home. So we need to split the, our text sentence by sentence, and obviously Spacey can do that, and it does that exceedingly well, but so it does have some dependencies, and in order to ship it as a LibreOffice extension, I chose to go with a slightly more lightweight solution that doesn't do anything or much else. So I use a package called Syntoc that uses heuristic rules to split sentences. And the idea is to not split at a dot in order to not get abbreviations mess you up or dates. Yeah, but it splits sentence by sentence, right? Yeah. Yeah, if not, I'd be out of business. Okay. Yeah. And so how to get the formatting? So the promise was that when you put in something that has kind of a word in italics or has a bold word, you get the same too. And so what we do is we can take this attention, which is, yeah, now I skipped the slide that tells you that the key in transformers is that instead of using a recurrence in the classical sense, it uses attention to have something like memory. And now you can get from OpenNMT, you can actually get these attention weights. And you see that it's kind of concentrated on the diagonal, which is just the alignments between source and target words. But so there's kind of a bad thing that looks at the dot. And I mean, it's Friday evening. Some of you might have looked at the clock to know when you can go home. And so the neuro-machine translation will do the same. Actually, I just deal with that by heuristics for the end bias. You could do something in the direction of attribution. This would be more accurate at the expense of increased computation. And so there's one of the other meetups here in Munich, a really great NLP and NLU meetup, where I have promised to give a talk on attribution someday. We'll just wait for that to do it properly. But for now, we just use the attention map to map the source words. And you see that it's kind of maybe a bit difficult because, so similar to what Ines told you, that you have the spacey tokens and you have the model tokens if you have one of those models. You have the kind of LibreOffice has an opinion on how to split text too. And so you have a matching problem here, but it's not that hard. The next thing you need in order to get something to the user, you need a user interface. That's not incredibly rocket sciencey, but as Ines has told you too, and they have this great Prodigy tool as a user interface for what their clients do. You need something here too. And so one large company that knows a thing about or two about word processors does the following. You mark a sentence and you click translate, and then you have the sentence here, and then you click translate, and then you get the translation, and then you click here and put it back. I thought I would just copy Microsoft because you can't go wrong with that. But so then the prototype fund program, they give you a kind of a user interface or user experience coaching. And so I had a second thought on that. And what I do now is, well, yeah, if you have to edit the text after it's translated, you might as well do it in the word processor. That's what they're for. And if you need the original text, you can just keep it as annotations. And if you're happy with it, there's a button in LibreOffice, delete all annotations, and they're gone. And so you can here, you see an actual example. So this is just an excerpt from a Wikipedia article on machine translation. And you see it does a lot of things good, but then there's kind of maschinelle Übersetzung, MU, will be kind of translated, not translated, or Menschheitstraum, humanity dream. It's maybe not a good translation, but if you look at the actual sentences, that's reasonably good. So this is how I made the UI look like. And when I proposed the project for the prototype fund, you have to write an application, what you're going to do for half a year. I thought, well, yeah, there's all these awesome visualizations. And then when I thought more about user interface and user experience, I thought, oh, yeah, well, but what's someone going to do with that? I mean, if I can click on a button, make it better, and then I don't need all of this. Maybe someone comes up with a version where you, I mean, one of the things that machine translation will get badly is that they will often mix up the gender. And it would be awesome if you could just say, well, yeah, this where you said he is a she, and then it would change it for all the occurrences, but we're not quite there yet. Probably if we did some higher order text analysis, that would work. So this is but about the UI. And then there's the thing that you need to do when you want to train a new model. Basically, because I just used the stock OpenNMT models, you can follow their tutorial. Obviously, you need a parallel corpus of sentences. And so there's one large one out there that's popular that has 4.5 million pairs of English to German. And you need to run this on a GPU for 1 or 2 weeks, which those have approximately 200 watts, or maybe 250. So you have 30 to 70 kilowatt hours per model, and obviously if I train 10 of these, my wife is going to ask me about the electricity bill. But okay. At least it's green power, so I don't have to feel that bad about it. But so really, I mean, that's part of it, and also when I do optimizations in PyTorch, I always have the idea that, well, maybe we can save some power when we're training all our models. And so you have very simple steps. You have some vocabulary preparation, which essentially means run sentence piece. Then you take the training, which is the hard part, and you do some evaluation. And in machine learning, it's just taking a holdout set and thinking about that. I always wanted to do a detailed tutorial on that. I've not done it yet. If you want to do this, obviously you're invited. And there will be very many happy LibreOffice users if you do. So far, this is about what I wanted to tell you about the modeling part. I've spent some thought since that how can you do the more modern things, and so one thing obviously is optimization. The thing is kind of slow. It's not awfully slow, but if you translate a 100-page document, you need some patience here because these translation things typically, I mean, you have between 50 and 200 tokens per second on a CPU, and OpenNMT has since released an optimized framework for inference, and you can do that. But knowing me, I probably try to fix PyTorch to be as fast as this benchmark. I mean, when you optimize things, it's always, if you have a benchmark, you have half the rent, because basically you know what's possible, right? And then there's model distillation. So Ines mentioned in passing DistilBERT from the Hugging Face people, where they just take like every second layer of DistilBERT, and they train one layer to do the work of two, and that works well. You could do this, or the OpenNMT people themselves. They train a simple RNN to do the work of the transformers. So transformers are less magic than we think, because you can just train an RNN to do the same. Neural networks imitating other neural networks, always a great recipe. There also are some thoughts into using BERT as an encoder, because everybody uses BERT these days. And there's some reports of what doesn't work, and there's also some people that say, well, yeah, if we initialize the encoder part of our model using BERT, then we get better results. But there's some computational expense there, and also the question is, well, how many languages do you actually have BERT for? I mean, for German and English, you probably don't need BERT to have a decent translation model. And you can always have faster training, of course. The other direction of improvement would be to kind of get a systematic view how to get data. So there's a project that collects open corpora. And funnily, one of the things is they use translated user interface strings, but I'm not sure what happens if you train a model on user interface strings and then use it to translate poetry. Probably sets you up for something that looks like these prototypically badly translated manuals that you have sometimes for electronic devices. Obviously, in the European Union, part of the core corpora to use are these parliamentary speeches, And similarly, if you want to start a legal tech, European legislation is obviously translated into all European languages, so you have a fairly large corpus there. And then there's also kind of the obvious questions: can we use word-by-word dictionaries too? And can we use weakly aligned texts? And actually, this is subject of active research. Last year and this year, the workshop on machine translation, they had a challenge where you should filter out things that are good pairs and bad pairs, so you can use not as well aligned texts and work with these. I thought I could use Gutenberg.org here easily, but nowadays you can't even access Gutenberg.org from Germany. Obviously you can work around that, but it's kind of a bummer if you have that in your project proposal. Yeah, I want to say something about LibreOffice here too. And personally, I use that a lot, except when making slides. Then I'm using LaTeX because I'm a mathematician. But so there's, I really like the people developing it. They're a great crowd. So the extension API, it's in Python, yay, but it can be very unwieldy because I mean, LibreOffice has a history of like 30 years of development, and it's all RPC style, indirection, abstract things, and very hard to debug. So the worst thing is that you write something and you start it and nothing happens because somewhere some message doesn't reach the endpoint or the reflection point that you want. But so people helped me a lot, and then even during the conference, someone took the time and helped me to get the LibreOffice bits fast enough to not be embarrassing. So that's good. The other headache kind of is the build process. So I have a few dependencies, notably OpenNMT and PyTorch, and then there's a few smaller ones. And so what I do so LibreOffice, it's a huge thing. And for example, on Linux distributions, typically it uses the system Python as its Python. And on Windows, you will typically install the package provided by the Document Foundation who develops LibreOffice, and that will come with its own Python. And so what I do is, for Linux users, I just ship the OXT, and if it needs to be, they need to use pip to install their dependencies. But for Windows users, who are the majority there, I just install those myself with pip, and then I copy all the whole directory of side packages into my extension, which kind of makes it 3 times faster. But the next step will be downloading a 300 megabyte model anyway, so it doesn't matter that much. But it will matter once we quantize the translation model, which is kind of one of the obvious steps. And if you follow PyTorch a bit, quantization in addition to mobile was one of the landmark features of the 1.3 release in October. Yeah, and so my dream is to maybe at some point make this part of LibreOffice proper. And for that, I would probably want to shed some dependencies and also port to C++. And obviously, with the C Translate thing OpenNMT provides, that's probably a lot less work than it would have been half a year ago when I started this. Yes, so if you want to install it, it really is very simple. You click once here to get the extension, and then you have a little configuration dialog that lets you just point it at the model, and then you're done. And you get the little extra menu entry. So, open source neural machine translation. One of the things that I really liked about this project is that it's advanced enough so you get something that's really practical that can translate actual texts, and yet you have a very active field, and also the OpenNMT people, they are very close to the cutting edge in machine translation. So you have lots of exciting improvements just over the year or so that I've been playing around with this. There was quite a bit of progress. Getting it ready for the user always is as much work as getting something to run. But so it's a real chance to also get community developed models, because obviously NLP kind of rests on having these models, and we all love Spacey because Spacey is great software, but we love Spacey the more because it has all the awesome models that I can just use out of the box, right? And so if you want to hack a bit on that, just give me a shout. I think it's a real fun thing, and obviously it can be useful to millions of users, because the user base of LibreOffice is quite large, and lots of non-technical people too, and lots of non-English speakers too. Yeah, and that's what I wanted to bring you.
That was amazing. Any questions from the audience? Come on, people. Oh, yeah. While I'm walking, I can ask. No, we have people like online or not, but I give you a microphone. What is it like? What kind of answer is that? What question was?
How fast are you translating?
Pardon?
How fast are you translating?
How?
How fast, when you are installed on the user's laptop or something, how quick is the translation?
It depends a bit on the exact configuration, but if you have bad luck, you can see it type the words.
Okay.
I mean, so there's various bits to that, and so one of my bad habits is, so I develop PyTorch a lot, and so half the time I have the debug version of PyTorch installed, and I never use virtual environments, so then LibreOffice Translate will use that too. But if you avoid that, it's actually that's not completely instant, but so after I fixed when I went to the LibreOffice conference, you could see the words being typed, and after the LibreOffice conference, you can see the paragraphs being typed. So it's quite a bit of improvement, but there's obviously more to be had.
You showed the attention matrix, and you showed the subwords on the German column. Is it specific to the German, or is it a general subword algorithm? I mean,
you mean if the tokenization is specific to German?
It looks pretty funny to separate the A from the U in Braune.
Yeah, so it is what you do is you just you do have usually common, or it's good to for some things it's good to have a common tokenization pattern for the source and target language, and the reason is that you can then you can copy words more easily. But so yeah, this is funny. On the other hand, I would doubt that the European Parliament discusses colors a lot. And so some of that is obviously the mismatch between this sentence and what it makes, and what the model is trained on.
Thank you. And then you said some people are translating the transformer model into simple RNN models, which I find very impressive. which I find very impressive. So you just need the transformer model for the training.
Yeah, so what they did, and so there's two parts of it, and I'm not sure whether it's a resolved story. So the people that do OpenNMT, they trained an RNN, which is kind of their lower resource model or the predecessor of the transformer models they have, and they trained it to imitate that to get a speed gain. And they too said they were surprised by how well it works. On the other hand, now, and this was implemented in a program called Translate, and now for Translate 2, they dropped the RNN support but only have transformer support. So I'm not sure whether that means, well, they've given up on it or they just didn't implement it first.
Thank you.
I mean, if I were to try something like that, I'd probably try the distillibird way of cutting out or combining layers of the model, right? So it seems that for some reason, these very deep models and the transformer models, they train better. But if you have the intermediate representations as a signal to train on, then you can train simpler models. And whether you want to halve the layers in the transformer or you want to move to RNNs. And I think they, even to squeeze out the last bit, they moved from LSTMs to GRUs, which are considerably harder to train. But you have 1/4 less computation in them. So I think it's something you can do, but and I always tell people when I do workshops on implementing things fast, I always say, well, yeah, changing the modeling is probably the first step over optimizing the implementation of the individual computational routines themselves.
Cool. And there've been also like quite a bunch of papers about distilling BERT, right? I think the last one was also like on mobile BERT, when they were able to do like question answering just like on device as well, and super fast as well. Yeah. Any questions still? No? Okay, maybe last question from me. Do you have any data how many users are kind of using that? Or did your mom start to use this translation as well? Where you started with?
Yeah, I don't have that much data. I didn't really keep track of it. So there's, there are some, I know that some people tell me what works for them, what doesn't work for them. But so I think to make it really useful, you have to have a lot more language models. And so in addition to, and there's two complications with that. First, obviously you have to have the data, but you also have to have someone who, if you want, owns the model. Yeah. And even with the rather large translation community in LibreOffice, it's a bit hard because you have language pairs. And I mean, so for the Romanic languages, you can also have a joint model where everyone has only one encoder decoder and they kind of can be mixed and matched. But it's an organizational question: who owns this model? If you want to kind of go into the, if you want to have community-built translation models.
Awesome, thank you. But I think it's super amazing that like millions of users can use it, so it's pretty cool. Thank you again for amazing stuff. So we again have like 5-7 minutes break, and after we have amazing like interview with those two exceptional personalities. So don't run away. Thank you. That's good. Pretty nice. Every time super nice. Different topics.
Yeah, next time I'll do